Before we can program a filter, we need to build an oscillator. An oscillator is a positive feedback system with a delay equal to the period of the signal. The gain through the loop must equal exactly 1. If not, the oscillation amplitude will either decay to 0 or it will grow towards infinity. The two-integrator oscillator uses the property of integration to convert a sine function to a cosine function. The cosine function converts to a negative sine function. Multiplying each integrator output by the desired radian frequency produces a loop gain of 1. An inversion of one output is required for positive feedback. The integrator can be modeled using discrete math. The simplest method is a first-order Euler integrator. Here is a model of the Euler integrator using a Z-transform delay. The discrete form of the oscillator is built using two integrator blocks. For the oscillator to be stable, the loop gain should be exactly 1. However, this simple integration method introduces an error term. The integrator n+1 output forms are different. The negative sine output has an extra dt squared sine of t term. The extra term adds a small error each time steps and results in an oscillation that grows unbounded. Without a limiter, the two-integrator oscillator is unstable with respect to amplitude. By forward tapping into the discrete integrator, the extra term is removed. The oscillator becomes stable. The oscillations are stable without the need for an output limiter. The stable oscillator is implemented using a simple program loop. The order of evaluation results in the equivalent of a forward tap of the second integrator. Now that we can program a stable oscillator using 2 lines of program code, the next step is to adapt the code for use as a second-order filter. State variable filters use 2 integrators to implement such a structure. X is a low-pass filter and Y is a band-pass filter. The output transfer functions are Here is the discrete form of the state variable filter. As with the oscillator, only 2 lines of code are required to generate each output step of the filter. Here is an Arduino program for a low-pass output step response. The underdamped response of the filter. Adios and happy experimenting!